Welcome to Artificial Intelligent Finances, the channel where we explore the intersection of AI and finance. Our goal is to provide you with insightful and educational content on how artificial intelligence is transforming the finance industry. From machine learning-powered trading algorithms to natural language processing-based chatbots, we cover it all. Join us as we dive deep into the world of AI and finance. Language models are the backbone of modern NLP, natural language processing, applications. They can be used for a variety of tasks, including sentiment analysis, question answering, text summarization, machine translation, and many more. One of the most famous LLMs is OpenAI's GPT-3 Generative Pre-trained Transformer 3, which contains 175 billion parameters and can generate human-like text with remarkable accuracy. GPT-3 has been used for a wide range of applications, from writing news articles to generating poetry. While LLMs have many exciting applications, they also raise concerns about potential misuse and ethical implications. For example, LLMs could be used to generate fake news or spread disinformation, highlighting the need for responsible development and deployment of these systems. With the advent of deep learning, the era of large language models has begun. Large language models, LLMs, are capable of generating human-like text that can mimic a human's writing style and language patterns. Preprocessing the data involves several steps, such as tokenization, stemming, and lemmatization. Tokenization involves splitting the text into individual words or phrases, while stemming and lemmatization involve reducing the words to their base forms. These steps help to reduce the dimensionality of the data and make it more manageable for the model. In this video, we will discuss how to generate, create, build, and train a large language model. 1. Choosing a dataset. The first step in creating an LLM is to select an appropriate dataset. The dataset should be large and diverse enough to capture the nuances of the language. Some of the popular datasets used for LLMs are Wikipedia, Common Crawl, and Books Corpus. These datasets contain billions of words, which is crucial for training an LLM. Once the architecture has been chosen, the next step is to train the model using the preprocessed data. This involves feeding the data into the model and adjusting the model's parameters until it can accurately predict the next word in a sentence given the previous words. Training an LLM can be a resource-intensive task that requires specialized hardware, such as graphics processing units, GPUs, or tensor processing units, TPUs. 2. Preprocessing the dataset. After selecting the dataset, the next step is to preprocess it. This involves cleaning the dataset by removing any unwanted characters, symbols, or words. There are several ways to obtain data to train a large language model, LLM. Scraping. You can use web scraping tools to extract data from websites. This is a common technique used to gather large amounts of text data from online sources. APIs. Many websites and platforms provide APIs that allow you to access their data in a structured format. For example, Twitter's API can be used to collect large amounts of text data from tweets. Datasets. There are many public datasets available that can be used to train LLMs, such as the Common Crawl dataset, which contains billions of web pages. Crowdsourcing. You can also use crowdsourcing platforms, such as Amazon Mechanical Turk, to collect data. This involves creating tasks that require human input, such as labeling data or generating text. Internal data. If you have access to internal data within your organization, such as customer feedback or support tickets, this can also be used to train an LLM. It's important to note that when collecting data, you should ensure that it's relevant and representative of the domain you want the LLM to specialize in. Additionally, you should consider the ethical implications of using the data and ensure that it's obtained legally and with the consent of the users whose data is being collected. Cleaning the dataset is an important step in preparing data for training a large language model, LLM. Here are some common techniques for cleaning datasets. Removing duplicates. Duplicate entries in the dataset can skew the training process and lead to overfitting. It's important to remove duplicates before training the LLM. Removing irrelevant data. The dataset may contain data that is not relevant to the task at hand. For example, if you're training an LLM for sentiment analysis, you may want to remove neutral or irrelevant text. Removing special characters and punctuation. special characters, punctuation, and other non-alphanumeric characters can cause issues during training. Removing them can make the dataset cleaner and easier to work with. Removing stop words. Stop words are common words that don't add much meaning to a sentence, such as and of. Removing them can reduce the dataset size and make it more efficient to work with. Tokenization. Tokenization involves splitting sentences into individual words or tokens. This can make the dataset more structured and easier to work with during training. Stemming and lemmatization. Stemming and lemmatization are techniques used to reduce words to their root form. This can help reduce the size of the dataset and make it more efficient to work with. It's important to note that cleaning the dataset should be done carefully to ensure that the dataset remains representative of the domain you want the LLM to specialize in. Additionally, it's essential to maintain the integrity of the data and not to remove information that may be useful for the LLM. This step is crucial as it helps in reducing noise and ensures that the model only learns meaningful patterns. The dataset is then split into training, validation, and testing sets. The training set is used to train the model, while the validation set is used to tune the hyperparameters, and the testing set is used to evaluate the model's performance. 3. Choosing a language model architecture. The next step is to choose a language model architecture. There are various architectures available for language modeling, such as RNN's recurrent neural networks, LSTM's long short-term memory networks, and transformers. Transformers are the most popular choice for building LLMs due to their superior performance and ability to handle long sequences. 4. Fine-tuning the pre-trained model. Instead of training a language model from scratch, it is common to use a pre-trained model such as GPT-2 Generative Pre-trained Transformer 2, or BERT bidirectional encoder representations from transformers. These models are trained on massive amounts of data and can be fine-tuned on a smaller dataset to achieve state-of-the-art performance in various NLP tasks. 5. Training the model. The next step is to train the language model. The training process involves feeding the model with sequences of text and updating its parameters to minimize the loss. The loss function used is usually the cross-entropy loss, which measures the difference between the predicted probability distribution and the actual probability distribution. 6. Evaluating the model. After training the model, it is essential to evaluate its performance on the validation and testing sets. The evaluation metrics used for LLMs are perplexity and accuracy. Perplexity measures how well the model can predict the next word in a sequence, while accuracy measures how well the model can classify a text into various categories. 7. Fine-tuning and evaluation. Once the LLM is trained, it can be fine-tuned on specific NLP tasks, such as language translation or sentiment analysis. Fine-tuning involves further training the model on a smaller, task-specific dataset, and optimizing the model's parameters for that particular task. The performance of the LLM can be evaluated using several metrics, such as accuracy, precision, and recall. These metrics provide an objective measure of the model's performance and can be used to fine-tune the model further or make improvements to the pre-processing and training process. 8. Deployment and maintenance. Once the LLM is trained and fine-tuned, it can be deployed in various applications, such as chatbots, language translation services, and text summarization tools. Deploying the LLM requires integrating it into the target application and ensuring that it is performing optimally in real-world scenarios. Thanks for tuning into Artificial Intelligent Finances. If you enjoyed this video, make sure to like and subscribe for more content on how artificial intelligence is changing the world of finance. Don't forget to hit the notification bell to be notified of our latest uploads. If you have any questions or suggestions for future videos, please leave them in the comments below. We'll see you in the next one.